Good morning, all of you. Dosto, in today's lecture, we have to study very important law, that is a Gauss law. A Gauss law we have already studied in 12th standard. That is, we know the statement for the Gauss law. What we have, that is total normal electric induction over a closed surface is equals to algebraic sum of the charges enclosed by that surface. That is, we have to study in the form of a total normal electric induction. Here we have to study the Gauss law in the form of electric flux. By using electric flux, we have to prove the Gauss law, first of all, an integral form, and after that we have to derive a differential form. Many times question may be asked on that for 10 marks. State and prove Gauss law and deduce its differential, integral and differential form. Like that question may be asked on that. Gauss law, its integral form and differential form. This is the target for today's lecture. First of all, we have to consider a Gauss law, and that Gauss law, what we have to consider, it is an important law in physics, and it is what we have to say that is a converse of the Coulomb's law. Coulomb's law we have to study in the last lecture. That is, we have to here study a Gauss law. According to Gauss law, what we have to state that according to Gauss law, we have to say that, what we have to say that is flux phi E is equals to Q upon epsilon 0. Q upon epsilon 0. This is what we have to say that according to the Gauss law we have to say that. Means we have, that is phi E is what? Electric flux, and Q is what? Total charge enclosed in that surface, and epsilon 0 is what? Permittivity of free space. And we have to say that is according to the Gauss law, that is the total flux phi E through the closed surface is equals to total flux phi E is equal to, this is what we have, total flux phi E is equal to, we have to say that total flux phi E through any closed surface is equals to 1 upon epsilon 0 times net charge, is equals to 1 upon epsilon 0 times net charge. According to the Gauss law, we have to say that total flux passing through the given area is equals to 1 upon epsilon 0 times a total charge. This is the total flux we have to consider for the Gauss law. And after that, we have to write that for the proof we have to consider differential form and a differential form, integral form and differential form of the Gauss law. We have to consider here, that is a flux. By definition of electric flux, what we have to say that by definition of electric flux, we have to say that is phi E. Phi is what? Electric flux, and that is equals to, we have to say that is surface integration of, surface integration is we have to consider over a closed surface, that is we have to say that yes, and it is what? E bar dot ds bar. Means finally we have to say that according to the Gauss law, a total flux phi, according to the Gauss law, total flux phi through any closed surface is equal to, what we have to do, is equal to 1 upon total charge enclosed is what? Q, and epsilon 0 is what we have? Permittivity. is equal to, we have to consider 1 upon epsilon 0 times 1 upon epsilon 0 times net charge 1 upon epsilon 0 times the net charge enclosed by the surface, net charge capital Q enclosed by the surface. This is according to the Gauss law, total flux phi E through any closed surface is equal to 1 upon epsilon 0 times 1 upon epsilon 0 times total charge enclosed by that surface. And by definition we have to say that electric flux is equals to surface integration of E bar dot ds bar. That is, we have to study in the last lecture. Flux is equals to what? E ds, E bar dot ds bar. But E bar is what? E bar is the electric field intensity, having formula is what? 1 upon 4 pi epsilon naught. 1 upon 4 pi epsilon naught into what we have to say that a total charge is considered as here, that is Qi divided by what we have to say that R square into R cap. What is R cap here? R cap is the unit vector, and here we have to write that this is what a direction of E bar. Here E bar is what? Electric field intensity. Theta is the angle between a normal component of the unit vector and electric field intensity. ds is the small element. Qi is the number of charges enclosed in that, and R is the radius of the spherical surface we have to consider, and therefore we have to consider that is phi E is equals to we have to write that here, that is surface integration of over the surface is considered say yes 1 upon 4 pi epsilon naught 1 upon 4 pi epsilon naught into Q by R square into R cap into ds bar. This is we have to consider here. But here these factors are what we have a constant that is taken out. 1 upon 4 pi is the constant. Epsilon 0 is the permittivity of free space. It is also constant. Q is also constant, and R square is also constant. And this is R cap and ds bar are in the same direction. So we have to consider that is surface integration of the closed surface, that is what we have to consider say ds, and that is equals to, we have to write that is 1 upon that is equals to 1 upon 4 pi epsilon naught into Q divided by what Qi, we have to write here Qi divided by what? R square into surface integration of this factor is considered as what? 4 pi into R square. And here this 4 pi is a cancel with this 4 pi. R square is also cancel with this R square. And finally it gets that, therefore phi into E is equals to, we have to write that 1 upon we have to write that what we have, that is say Q into I divided by what? Epsilon naught. But that is also equals to, we have to write that is Q into I is nothing but what? Summation of Qi divided by what? Epsilon naught. And finally we have to write that this is the total electric flux we have to consider, and that is equals to what? Q upon what? Epsilon naught. And this is the statement we have to consider, that is phi is equals to, means finally we have to write that, therefore what is the phi? Phi is nothing but what? Surface integration of, phi is nothing but what? That is, we have to write that electric flux phi means we have to consider that surface integration of E bar dot ds bar, E bar dot ds bar is equals to q enclose divided by what we have to say that epsilon naught, and this is integral form of a Gauss law. This is integral form of Gauss law. Integral form of the Gauss law. Basically we have to consider here. This is the integral form of Gauss law. Phi is nothing but what? E bar dot ds bar, and we have to substitute in this value. It gets that E bar dot ds bar is equals to E enclosed into epsilon 0. From this we have to write the statement for the Gauss law. Now what is the statement? Now statement is what we have, that is we have to write that a Gauss theorem states that the surface integral of, that is what you have to, Gauss theorem states that Gauss theorem states that the surface integral of the normal component of the surface integral of the normal component of electric field surface integration means what we have. This is the surface integration. Gauss theorem states that the surface integral of the normal component of electric field over any closed surface, normal component of electric field over any closed surface, surface integral over any closed surface is equal to 1 upon epsilon 0 times, is equals to 1 upon epsilon 0 times total charge or net charge enclosed by that surface. This is the statement we have. From this we have to write that the statement is considered as here. This is what we have, that is surface integral. The Gauss theorem states that surface integral of the normal component of electric field over any closed surface is equal to 1 upon epsilon 0 times the total charge enclosed by that surface. This is the statement of the Gauss law we have to consider here. And this is what we have to say that equation number say 1, that is we have to consider here, that is surface integration of E bar dot ds bar is equals to E enclosed upon epsilon 0, means we have to write that transforming किंवा converting, transforming च्या वेळी आपण काय म्हणू, converting surface integral to volume integral or surface integral to volume integral by divergence theorem. Now what is the divergence theorem we have? That is surface integration of E bar dot ds bar over the surface S is equals to volume integration of divergence of E bar, volume integration of divergence of E bar into ditto, divergence of E bar into ditto. This is equation number say 2. From equation 1 and 2, we have to write that. From equation 1 and 2, what we have to write that? That is, left hand sides are similar. Therefore, we have to write here, that is volume integration of divergence of E bar into ditto is equals to Q enclosed divided by epsilon 0, equation number 3. Q enclosed divided by 3. Now, here we have to consider what is the proof of, we have to consider for the differential form. First of all, we have to consider all these things for the up to this point, and after that we have to remove, and then we have to deduce the differential form. First of all, we have to understand what is a Gauss law. According to Gauss law, we have to say that total flux phi through any closed surface, total flux phi through any closed surface is equal to, this is very important, phi is equals to what? Q enclosed divided by epsilon naught. Q enclosed divided by epsilon naught, where Q is the total charge enclosed in that surface, R is the radius, small ds is considered as what? ds is called as what? A small element, and at a point A, and E bar is the electric field intensity, and R cap is what? Unit vector. After that, we have to proof of an integral form and differential form of Gauss law. How it is? The first of all, we have to know what is electric flux, and after electric flux, we have to say that phi is equals to E bar dot ds bar. But E is the electric field intensity. This formula is, we have to know that E is equals to 1 upon 4 pi epsilon 0 Q upon R square. In a vector form, we have to write the R cap. Substitute this value in E bar, it gives that this form. And here, all the constant factor is taken out from the integration 1 upon 4 pi epsilon 0 Qi upon R square, and it gets what? Surface integration of ds. And this is a sphere, and sphere having area is what? 4 pi R square. So here we have to use the 4 pi R square. Now 4 pi is 4 pi, 4 pi cancel, R square is also cancelled, and it gives that phi is equals to, only remaining is what? Qi upon epsilon 0. And now what is Qi? Qi is the whole charge. What is the whole charge now? We have to consider that Qi is equals to Q1 plus Q2 plus Q3 dot Qi. And then we have to say that that is considered as what? Q enclosed. This is considered as what? Q enclosed and divided by epsilon naught. This is the phi. But what is the formula for phi? Phi is nothing but this. And that is what we have to use here. Surface integration of U bar dot ds bar is nothing but the phi. And phi is equals to what? Q enclosed upon epsilon 0. This is called as what? This is called as what? Integral form of Gauss law. Last common answer, integral form of Gauss law. Now what is the second target? We have to differential form of the Gauss law. From this, what is the statement? We have to say that Gauss law states that, the Gauss theorem states that the surface integral of the normal component of the electric field over the any closed surface is equal to 1 upon epsilon 0 times the total charge enclosed in that surface. This is the statement. And after that, converting the surface integral, that is the surface integral converted into volume integral, it gives that surface integration of U bar dot ds bar is equals to volume integration of divergence of U bar dot dou t. And this is equation number say 2. From equation 1 and 2, we have to say that left hand sides are similar and right hand side are also similar. So we have to write this equation, that is divergence of U bar dot into ditto is equals to E enclosed divided by epsilon naught. Now one more point we have to write here, that is very important for the Gauss law, for the differential form of the Gauss law. We have to write here What is the next point we have? That is a charge. What is the charge now? That is Q enclosed is given in terms of charge density. Now Q enclosed is given in terms of charge density. We know the surface charge density, volume charge density and linear charge density. Linear charge density means charge per unit length. Volume charge density काय असते? That is rho is equals to what? Charge per unit volume. Volume is we have to consider here what? D2. Means we have therefore Q enclosed ENCL is equals to volume integration of rho into d2, and this is equation number 4. And from equation, so put this value in equation 3. Equation 3 मध्ये आपण ही व्हॅल्यू टाकू. काय 3 नंबर आपला? This is the 3 number. That is volume integration of divergence of E bar into d tau is equals to, what is the value of Q enclosed? That is 1 upon epsilon naught as it is into integration of rho into d tau. Now we have to epsilon 0 comes in the integration, that is volume integration of divergence of E bar into d tau is equals to volume integration of rho upon epsilon naught into d tau. Now here we have, this is plus in the right hand side, it takes in the left hand side a common integration, that is divergence of E bar, and this is what we have, minus rho upon epsilon naught into d tau is equals to 0. And here volume integration is vanish. Therefore we have to write here what we have, as for any arbitrary surface volume integral should be equal, and hence we have as volume integral is equal. Therefore divergence of E bar minus rho upon epsilon 0 is equals to 0. And finally we have to write that divergence of E is equal to rho upon epsilon naught. This is the one more formula we have to derive here, or this can be called as what? Divergence of E bar is equals to rho upon epsilon naught. This is differential form of a Gauss law. This is Gauss law. This is the differential form of Gauss law. Very simple we have. First of all, we have to one step is what? Surface integration of E bar dot ds bar is equals to E enclosed upon epsilon 0. This is one equation. And second equation, convert this surface integration into volume integration. We have to use what? Which theorem? Gauss divergence theorem. And Gauss divergence theorem used here. That is surface integration is converted into volume integration, equation 2. From 1 and 2, left hand sides are similar. We have to equate the right hand sides. And right hand sides are volume integration of divergence of E bar dot d2 is equals to E enclosed upon epsilon naught. And then we have E enclosed is what? is given in terms of charge density. Charge density is what? That is charge per unit volume. Charge per unit volume. And that is, volume is considered here d2. We have to use dV also. But here we have to use d2. 2 is the volume. And put this value in equation 3. It gets that divergence of E bar dot d2 is equals to 1 upon epsilon 0. Volume integration of rho into d2. And here, both sides we have volume integration. Volume integration is vanished with volume integration. And finally, directly we have to get that what? Divergence of E is equals to rho upon epsilon 0. Or we have to, this is common taken, and after that finally vanish the volume integration. And basically we have to get that, what we have? Divergence of E bar is equals to rho upon epsilon 0. Or we have to write that divergence of E bar is equals to rho upon epsilon 0. And this is called as what? Differential form of Gauss law. This is called as what? Differential form of Gauss law. This is very important law. Many times question is asked on that for 10 mark. What question we have? That is state and prove Gauss law. Or we have to question maybe ask on that, that is deduce the differential integral form and differential form of the Gauss law. Statement we have to remember. What is the statement? That is, we have to consider, that is, surface integration of U bar dot ds bar is equals to Q enclosed upon epsilon 0. Means we have surface integration of normal component of electric field intensity is equal to 1 upon epsilon 0 times a total charge enclosed in that surface. This is very important. Integral form is this one, and differential form is divergence of E is equals to rho upon epsilon 0. Many times multiple choice question may be asked on that. What is the differential form of Gauss law? Okay, I hope we have to understand. Very important article. Write down all the points, and after that we have to continue next period. Write down this. Right. Thank you.